In which compound are the valence electrons most equally shared between the bonded atoms? And then we have A, B, C, or D. So we have a choice of 4, right? Are the valence electrons most equally shared in a CH bond, an HF bond, NH, or OH? Okay, great question. Now, if electrons, specifically valence electrons, because remember, those are the only electrons that are making covalent bonds, if they are the most equally shared, that means that if you have a bond, right? Remember, a single bond is always just 2 electrons. So if you have a bond between 2 atoms and you want it most equally shared, those electrons have to be split right down the middle. Or at least as close as split right down the middle between the 2 atoms, between the X and the Y, whoever that is, right? The C and the H and the F, etc., etc. So that means that there is no pulling. We don't want an atom to be selfish and shellfish. No shellfish, guys, okay? I'm sorry, but shellfish. Selfish shellfish. Oh my gosh. Shellfish is good. That's all. But no selfishness here. So that means that we don't want an atom to be greedy. We don't want the atom to attract these electrons. We don't want the electrons to be pulled towards the Y or pulled towards the X. We want them beautifully right down the middle. This type of bond is called a non-polar bond. And by definition, a non-polar bond comes from, and you know, all this pulling and selfishness, a non-polar bond or polar bond is defined by electronegativity. Electronegativity is the property to determine what atom is more selfish. And for a nonpolar bond, we need an electronegativity difference, which just means subtraction. You're just going to take the numbers, so the subtraction, to be roughly between 0 all the way up until 0.4. So very, 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 very small numbers here. But in order to generally find out those electronegativities for these atoms, we must go to our periodic table. Now, if you are only given a periodic table that doesn't have electronegativity values, you just have to know the general trend, which we will see on our chart. So let's head on over there. So here is my lovely electronegativity periodic table that I made for you guys. All of the electronegativity values are down below. So like hydrogen is 2.2, carbon's 2.5, 3, 3.54, etc., etc. You could pause the video if you want, take a good look at this, right? But you'll notice that the highest electronegativity value is fluorine, which is 4.0. We're not talking big numbers here. But just know that the highest is the F, and the lowest is the other F guy, who's all the way down at the bottom. So the lowest roughly is francium, with cesium, but it's diagonal to diagonal. So francium is the lowest possible, so F to F. Francium to fluorine. We will be increasing as we go from this way. So if you guys don't have, what's going on here? Oh boy. Oh, there we go. If you guys don't have these numbers available, you could just remember the general trend of electronegativity. And knowing the general electronegativity trend is also good to know as well. I'm going to just pick out these values. So I believe there was a hydrogen, so I'll use 2.2. And then they increase by 0.5 as we go along this period. So carbon's 2.5, 3, 3.5, and 4.0. So with those, let's go back to the question, write them in, and then we'll be able to determine the answer. So let's go for it. Okay, so we're back. So all of these bonds have the hydrogen, so that's the thing that stays constant. So, and on that periodic table, it was 2.2. So I'm just going to write 2.2, 2.2, 2.2, 2.2. And they were increasing by 0.5s, right? And we said that fluorine was the most electronegative element. So that's going to have a lot of pull. Fluorine is like, gimme those electrons. And then we'll drop by 0.5. So nitrogen, nah. So this would be 3.5. Then comes nitrogen, which is 3. And then comes carbon, which is 2.5. Let's find out those electronegativity differences. And for electronegativity differences, all we have to do is just take the higher number and minus the lower number. So if you get a negative value by subtracting a lower number minus the higher number, just make it positive, because electronegativity difference is always going to be a positive value. This minus just means that we were subtracting. But just know that electronegativity is always the absolute value. So if we do take these guys and subtract them, we get 0.3, If we subtract these and make it positive, what is this, 1.8? If we subtract these, we get 0.8. And if we subtract these, we get what? We got a 0.8. And then 5. What is that? 1.3? Okay. And as we've seen, this is the highest number difference, electronegativity difference. We did say that fluorine is the most electronegative element, so it's going to be the most greedy, the highest difference. That means that in this bond, those electrons are going to be super close to fluorine. But we don't want that. We want most equally. So that means that we want the lowest value. And remember, it's got to be from 0 to 0.4 if we are saying that it's nonpolar. And there's only one nonpolar bond here, and that is CH. That electronegativity difference is 0.3. That is a nonpolar covalent bond. All these other ones, since they are greater than 0.4, this would be polar bonds. And there we go. So the answer here, most equally shared, is the CH bond. And just know, for memorization's sake, if you see a CH bond, it is always going to be classified as nonpolar. Carbon to hydrogen bond is one of your most important bonds to memorize, especially if you're going into the medical field, organic chem, we all love it, biochem, physiology. You're going to see tons and tons and tons of CHs. So it's always good to just have that in the back of your mind. All right? So this was fun. Thanks for hanging out. And if you want more practice, head on over to glazersguide.com. The link is in the description to have more questions in this topic. Thank you guys, so much fun. Over there, we're going to have so much practice, which means so much fun. I hope you guys have a great day, and I'll talk to you soon. Bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.